Hello everyone, welcome to my channel Chemistry is Fun. So students, today we will be studying about solid state. So first of all, what is a solid state? It is a state of matter where the constituent particles are very closely packed together. Then we call it as a solid. These constituent particles may be atoms or ions or it may be molecules. And there is a strong interaction, that is a strong attractive force between the particles in case of a solid objects. Therefore they have a certain shape, mass and volume. Now as I just told you, in case of the solid, the particles are very closely packed and these are also held by strong intermolecular attractive forces. Since they have a strong intermolecular attractive force between the constituent particles, they have a definite shape and volume. They are not like gases and liquids. They don't have a definite shape or volume, but in case of solids, they have a definite shape, they have rigidity. This arises from the fact that the constituent particles are not having enough energy so that they can move about or they can take up different positions. It's not possible in case of solids. Therefore, there is a definite volume. And the volume also does not depend on the size or shape of the container. This arises because of the close packing of the molecules. So, this definite shape and volume is because of close packing of the molecules. They also exhibit high density and as a result low compressibility. The high density is because of close packing of molecules again. So there is not much free space between the molecules. The space between the molecules is very less. So they are having high density and therefore they cannot be compressed. There is very less space, very less free space between molecules. This leads to their high density and low compressibility. They also show very slow diffusion. The diffusion in case of solid is negligible or very slow because the particles have permanent position and they are not able to move easily from their position. Next we come to vapor pressure. The vapor pressure in case of solids is very less if we compare with the vapor pressure of liquids at a particular temperature. Because in case of solids, there are only some particles near the surface which may have enough kinetic energy so that they can move away and enter into the vapor state. So the number of these particles is very less. So the vapor pressure is also quite less. Next we come to melting point. Melting point refers to that temperature at which the solid and the liquid form of the same substance will exist at equilibrium. There is equilibrium between the solid and the liquid state. And we can say that at that time they have the same vapor pressure. So this is the condition for melting point. Whenever we are supplying some heat energy to a particular substance, the particles will get sufficient energy and then they start moving away from their fixed positions. They will move because they gain energy. So we get a liquid state. The intermolecular space will increase. So from the solid we arrive at the liquid state. But when a particular temperature arises, when there is an equilibrium between the solid and the liquid state, we call this temperature as the melting point. The value of this melting point will depend upon the strength of the binding energy because we have to break the binding energy so that the molecules that is the constituent particles gain sufficient energy and they are able to break away from their already having fixed position. They have to move away from that. So if the binding energy is very high, more energy has to be provided so that they can just break away that binding energy and they move away from their destined fixed positions in space. There are some solids which I'll explain afterwards, which are called as amorphous solids. In them, the melting point is not sharp. They don't have a sharp melting point. Now we come to the classification of solids. First is crystalline solids. Crystalline solids are that in which the building constituents, they are arranged in a regular manner. Okay, there is a regular arrangement. The constituents arrange in a regular manner throughout the three-dimensional network. So they are arranged in a regular manner. In the three-dimensional network. So there is a ordered arrangement. And this ordered arrangement will extend over a large distance. So we can define a crystal as a solid figure which has a definite geometrical shape with flat faces and sharp edges. So crystal is a solid figure which has a definite geometrical shape with flat faces and sharp edges, and they also have a sharp melting point. The crystalline solids have a definite and regular geometry because, as I just told you, the constituents are arranged in a regular manner. They have very sharp melting points. This also arises from the fact that there is an orderly arrangement and this extends over a large distance. They have a long range order. We can say crystalline solids have a long range order. They have sharp melting points. Now see, if we see anisotropy, there is a phenomena called anisotropy. Anisotropy is there. The crystalline solids, they are anisotropic. Now what is this? Is a new term for you all children, so please see what it is. In this figure you see I have shown the arrangement of constituent molecules in a crystal. There are two types of molecules you can see. Alternately I have shown them with red dots and blue dots respectively. Now you see there is an alternate arrangement. Now see, whenever we are measuring any physical property along the slanting line CD, along this line if we measure any physical property, it will be different from the measured quantity in the direction of the vertical line AB, because you see in the line CD there are alternate types of atoms. Here you see in the line CD the atoms are alternate, red, blue, whereas along the line AB only same type of atoms are arranged. So the same physical property for the same crystal will not be the same in both the directions if we change the direction of measurement. This is known as anisotropy. And this phenomena also provides a strong evidence for the presence of ordered molecular arrangement in the crystals. This shows that anisotropy also shows that there is an ordered molecular arrangement in the crystals. So this is all about anisotropy. The crystals are rigid and their shape cannot be distorted by mild distorting forces, because there is a ordered arrangement and that is in the long range, means for a continuous extending over a large distance we find this orderliness. Crystals are bound by plane faces. If you see the faces of a crystal, they are plane faces, and the angle between any two faces is called as interfacial angle. The angle between any two faces is called interfacial angle. And for a given crystalline solid, it is a definite angle and it will always be constant. Okay. And if we hammer, by chance you hammer a crystalline solid, it will break up into smaller crystals. But the same geometrical shape will be there. It will break up into smaller crystals of the same geometrical shape. Very important property of crystals is their symmetry. We have plane of symmetry, axis of symmetry, and center of symmetry. Now these types of symmetry in crystals I will take up in a new class. So there are three types mainly: plane of symmetry, axis of symmetry, and center of symmetry. Whereas if we see the amorphous solids, in the amorphous solids there is no pattern in the arrangement of the atoms or ions or molecules. That is, the constituent particles are not having any regular pattern of arrangement. So they do not have any definite geometrical shape. And they do not have any sharp melting point. They do not change abruptly into liquids. They do not have any sharp melting points and do not change abruptly into the liquids. They are isotropic. I told you about anisotropy in crystals. They are just opposite. They are isotropic. Because here the arrangement of the building constituents is random. The building constituents arrangement is random and disordered. The arrangement of building constituents is random and disordered. There is no order. Because of this, all the directions are equal. So the properties are same in all the directions. So they are isotropic. They are not very rigid and they can be easily distorted by compressing forces because orderliness is not there. They do not have well-defined planes. They do not have well-defined planes. Any amorphous solid is broken. If we break any amorphous solid, the surfaces of the broken pieces are not flat and they will intersect at random angles. We find that they will intersect at random angles. And because of all these properties, the amorphous solids do not have any symmetry. They do not have any symmetry. So students, I hope you could understand the topic which I have discussed today. And in my next video, I will definitely discuss about the types of symmetry in crystals. Thanks for watching my video. Please subscribe to my channel if you have not done it yet. Thanks for watching. Thank you all.